Compound interest rates. For this video, we're going to work with two different formulas. The one on the left and right, A equals P times 1 plus R over N raised to the NT, and then A equals PE to the RT. Before I do any examples, I have to define what each piece of these formulas means. And so I'm going to list out all the variables. There's an A, a P, an R, an N, and a T. All right. So even before this, these types of formulas are used to find end balances of certain investments. They measure exponential growth and exponential decay. And so a lot of times, if you invest money, let's say at a certain amount of an interest rate, at the end of the year, or at the end of the investment, however many years it is, it'll give you a new amount, and probably an amount that's more than the original investment. That's how that works. And so A is the ending balance of that investment. P is the initial balance, or what you actually invest. R is the interest rate in which the loan exists with. N is the number of times compounded. And T is length, usually in years, of the investment or the loan, whatever it might be. Car loans are another example of this, exponential decay. You take out a loan for a car, you have interest on that loan, and you take it out for a certain amount, and by the end you pay a little bit more than what you borrowed because of that interest, right? So, this formula, there's an A, a P, an R, and a T. They're the exact same thing. This E actually stands for a specific number, but we'll just leave it at that for now. All right, so I'm going to do 3 examples. These examples differ based on the number of times compounded. So for each example, this N is going to be different, all right? Now, for number 11, interest compounded annually, all right? So if I was reading a word problem and I saw the word annually, I know that my N would be 1, all right? So let's do this. Initial deposit of $5,000. Initial deposit, to me, looks like it lines up with P, initial balance. So I know my P is 5,000. All right? Into a savings account that compounds an interest rate of 7.1% annually. There's that key word, annually. Now, my R is 7.1%. But mathematically, I need to turn that into a decimal because I use decimals with the formula. So if you remember, if it's percentage, you move the decimal point 2 places to the left, so it becomes 0.071. This is my interest rate, 0.071. Now annually tells me that N, the number of times it compounds in a year, is just once, annually. So N is 1. And then finally, how much is in the account at the end of 5 years? So T is 5 at the end of 5 years, and then how much is in the account? It looks to me like A, the ending balance, is the unknown. All right, so I need to solve for A. This is pretty straightforward, so I'm going to use this formula because I have every piece of that information, and I'm looking for A. This formula goes with another keyword I'll talk about in just a little bit, all right? So I have A equals, instead of P, I'm going to put 5,000, parenthesis, 1. And in this case, it's plus because you're earning money on it. It's an investment, right? If it was a car loan, it would be minus, meaning it would depreciate over the length of the term. So I'm going to put plus. Now, my R goes on top, and I put it in decimal form, 0.071. My T goes on the bottom. Never mind, not T. N goes on the bottom. So N is 1 in this case. And then I raise it to the 5 times 1. And you could put 5 parenthesis 1. You could put 5 times 1 in your calculator. It doesn't matter. NT, I did TN, same thing. Multiplication is, well, to make it happy and satisfied. N is 1, T is 5. All right. Once I've discovered every piece of what the variable is in the problem and I've input it into the formula, then all I have to do is simply put that into my calculator exactly like you see it. So I'm going to take a calculator. I'm going to type 5,000 parenthesis 1 plus. I'm going to hit alpha y equals to bring up my fraction bar, and I'm put 0.071 on top, 1 on the bottom. Then I'm going to hit over, close the parenthesis, and then I hit the arrow key or the power key and do 1 times 5 in the powers. Please do that along with me so you can check that you know how to do this on the calculator. I hit enter and I get an ending balance of A equals 7,045, or 7,045, yes, 0.59, let's say. So after 5 years at that interest rate, compounding only once over that time, you make about $2,000. So that's a pretty good interest rate. And that is how you would answer this type of question. The question was, how much is in the account at the end of 5 years? You found it via that formula. So make sure again that as you punch that into the calculator, you got 7,045.59. All right? Now, moving on. If you notice, and before we start, let's change this to 4. All right? Change that to 4. Compounded monthly. The only difference here is that N was 1 for annually. Now, monthly, you got to think, this is a key word here. Monthly, you got to think, how many months are in a year? 12. So it's going to compound 12 times within each year. So that is going to change the N value. Other than that, it's the same thing. Let's change that to 4 as well. So let's read the question. Your allowance of 190 got 11% compounded monthly for 4 years. What's it worth after the 4 years? So again, this to me, 190 looks to be the beginning value, because that question, what is it worth after the years, seems to me the unknown ending value. So I'm going to say P is 190. R is 11%, but remember we got to move the decimal point 2 places. It's here. I move it 1, 2, so it becomes 0.11. And in this case, the key word for my N now is monthly, and I said that already. N is 12 months in a year, so N is 12, and T is 4. We said I changed it to 4 to make it a nicer number. So again, we're looking for A. A equals all of that. So go ahead at this point, pause the video, and try to come up with your own answer for this process. Plug that into the formula, and then come up with your own answer. So please pause the video and try that. At this point, you should have paused the video. I inputted this into the calculator, and I got 294.42 for my answer. So please check your work with mine. Now, finally, compounded continuously. If I read this question, an account earns 6.6 interest compounded continuously. This word right here, continuously, tells me that I need to use this formula. This is the continuously formula, all right? So it's going to look a little bit different. I'm going to rewrite it so I can reference it. A equals P e to the R T. Same pieces though. An account earning 6.6 interest. So this is my R. 6.6 becomes 0.066, right? I have to move it 2 places. 1, 2. Then 10 years is my T. And then how much would it have a balance of, or it would have, how much of a balance if the principal is another word for beginning. So if the principal investment was $550, how much would it have at the end of its life, or at the end of those 10 years? So in this case, I'm still trying to solve for A, the end balance. I have a 550 for a P. E is a number on your calculator, and then raised to the, in this case, 0.066 times 10. And you can put it in your calculator exactly like that. If I find my calculator, I'm going to put 550. Now, E, if you hit second, there is in blue, it's E to the X. You can hit second and then the LN button to bring up that option. Or there's an E on the right-hand side as well. But I'm going to hit second LN to bring up E, and then it automatically gives me a power. And in that power, I'm going to do 0.066 times 10. And my final answer, A, equals 1064.14. Make sure you got that on your calculator so that you know how to enter it into the calculator correctly.